Hello everyone. In this video I'm going to be talking about circle geometry. So I'm going to be doing this in terms of examples, so I'm not really going to be going through theory. Just so you know, I haven't done these questions previously, just so that you can understand my thought process, right? So I've gone through them roughly, but haven't really done them thoroughly. So okay, I'll tell you what the three examples are. So in the first question, they're given me this this shape in a circle, right? And what they want me to find is theta. Or rather, they want me to show that theta is equal to 90 degrees. They've given me that this triangle ABC is isosceles, and that's all the information that I have. Okay. In the next question, what I have is a circle, and I have a cyclic quadrilateral, right? They tell me that this is a parallelogram, right? So this is a parallelogram. What they want me to do is to show that this has to be a rectangle, right? Or rather, in other words, I need to show that this is 90 degrees. And in the last question, again, it's a cyclic quadrilateral, but what they want me to find is this angle theta and alpha up here. Okay, let's get started. So coming back to the first question. Right, now, in any circle geometry question, what I personally do is I blindly write down all the information that I have. Okay, so all the information that I can get, sorry. So I know that that's isosceles, so the most obvious thing to say is that that angle is going to be equal to that angle. All right, so let me call this angle, say, alpha. Okay, so and that's going to be alpha as well. Now it turns out this alpha angle over here is going to be equal to this angle over here, right? So I have an alpha angle. The reason being, if you look at this, so let me choose another color. Okay, so if you look at this thing, it's the same segment, right? So it's sitting on the same chord. If you look at these two things, it's sitting on the same chord. So those, forgive my rough drawing, but anyway, so it's sitting on the same chord AB, right? So because of that, this angle is going to be equal to that angle. The reason being, it is in the same segment, right? The reason is it's in the same segment. All right, so what else can we find? Now, one other thing that I failed to mention was that AD is the diameter, right? Because AD is the diameter, I know that my angle ABD is going to be equal to 90 degrees, right? The reason being the angles on a diameter. So let me just write that down, angles on diameter. Okay, so what else can we find out? So I really need something relating theta to alpha. Okay, so I know that's going to be 90 degrees. And this angle over here, that angle there has to be equal to 180 minus theta minus alpha, right? Simply because this is a triangle, right? And the sum of the angles inside a triangle is going to be 180. Okay, so now we got pretty much everything that we need to know. So let's write this out formally. So I know, so DBE, angle DBE is going to be equal to 180 minus theta minus alpha. And as for the reason, you need to write sum of angles in triangle. And we also know angle DBE is equal to 90 minus alpha, angles on a diameter. So now what we really have is an equation. So let me scroll down. So I now have that 180 minus theta minus alpha is equal to 90 minus alpha. Right, so taking the So basically, the minus alpha will cancel out with the minus alpha, right? Taking the 90 onto the other side, and this theta onto this side, I will end up with theta is equal to 90 degrees. Okay, so there you go. So coming back here, I have proved that theta is equal to 90 degrees. Okay, let's move on to the next question. Now this question is actually going to be easier simply because there aren't too many cluttering, and it's fairly easy to see. Now let me name this and call this ABCD. Alright, so remember what I need to prove is that this parallelogram is actually a rectangle. What I can say is that this angle over here, let's call it alpha, is going to be this angle over here, simply because it's a parallelogram, right? So opposite sides of a parallelogram. So I'll write it down and say BAD is equal to angle BCD, opposite sides of parallelogram. Okay, so let's call this alpha. Okay. Okay, and I also know that this angle over here, angle BAD, has to be equal to 180 minus angle BCD. Right? So basically it's saying alpha has to be equal to 180 minus alpha. So coming back to the reason being, this is cyclic quadrilateral. So in a cyclic quadrilateral, the opposite sides have to add up to 180, right? So that's a theorem. So the opposite sides add up to 180. So I'll just say opposite, sum of opposite sides of a cyclic quadrilateral. So it's not any quadrilateral this works, right? It only works for a cyclic quadrilateral. So a cyclic quadrilateral being a quadrilateral inside a circle, right? Touching the circle. It has to be touching the circle as well, right? So it's touching the four corners, right? In that case, you have this. So we have these two equations, right? And we know that this is equal to alpha. And now we can get this final equation. So now I will get 2 alpha equals 180, and therefore alpha equals, which is going to imply alpha is equal to 90. Okay, so if it's 90 degrees, that means this is a, therefore, rectangle. Okay, alright, so let's move on. And the last question, so the last question is asking me to find theta and alpha. Okay, so I need to find these two angles over here, theta over here and alpha. Okay, let's start off with, again, I'm just going to blindly write down everything that I know. Alright, so this 50-degree angle over here, it's going to equal this angle. So this is also 50 degrees. The reason being, it's the angle on a tangent is equal to the angle on the opposite segment. Now this, some people find it quite hard to visualize, right? So the easiest way to do this, right, is to draw a Z. Sorry, my mistake. So let me start up again. So if I draw a little straight line from here up to here, if I draw a Z, okay, let me do that one more time. So we look at this Z that we see over here. So this thing, so that's sort of like a Z, right? So forgive my wonky hands, but that's sort of like a Z, right? So effectively, in a parallel line situation, what you would end up saying is that this angle over here is equal to this angle, right? When we have a tangent to a circle, what you end up saying is that it's not the Z angle, but the one opposite to it. So it ends up being that angle over here. So I know that that's equal to 50 degrees. But the thing is, this tangent, Okay, so sorry, my mistake. It's this one over here, not this one. Okay, in the same way, this theta over here is going to end up being equal to this angle, so that's going to be equal to theta. All right, so what else do we know?